Hey Chem classes, today we're going to be wrapping up stoichiometry with the last concept, which is percent yield. So percent yield attempts to answer two questions. How much product should you have made, and how much product did you actually make? And that gives us the formula for percent yield. The experimental yield, or the amount of product that we actually made, divided by the theoretical yield, or the amount of product that we should have made. And of course, to make it a percent, we multiply by 100%. Let's go back to our sandwiches for a second. So remember that when I was making grilled cheese sandwiches, I had 10 slices of bread and 21 slices of cheese. And my calculations told me that I should have been able to make 5 sandwiches. So that's my theoretical yield, 5 sandwiches. You'll remember that in my example, unfortunately, I burnt one of my sandwiches. And there's lots of reasons why you may not have 100% efficiency when you're performing chemical reactions too. But let's find out what my percent yield is for this reaction. What I actually got, my experimental yield, over what I should have gotten, my theoretical yield, times 100%. So for this example, I should have gotten 5 sandwiches, but I only got 4. So 4 out of 5 times 100% is an 80% yield. Let's take a look back at the last extra example that I did and see how we can add percent yield to one of these problems. So if you recall, in this experiment, I started with 3.25 grams of ammonia, and I was allowing that to react with 3.50 grams of oxygen. By the end of this problem, we had determined that oxygen was the limiting reagent and that 2.63 grams of nitrogen monoxide could be formed. So now let's add percent yield on top of this. Let's say we do this reaction, but instead of getting 2.63 grams of nitrogen monoxide, I only form 1.98 grams of nitrogen monoxide. What would my percent yield be? Well, again, my formula says percent yield is the experimental yield over the theoretical yield times 100%. So do that calculation and tell me, what would your percent yield be? You should have gotten 75.3%. Now you may be asking, is that good? Is that bad? I don't know, because I'm not sure about what the efficiency of this reaction should be in a lab like a classroom or in a lab like an industrial complex. And that will really depend on the individual reactions and the environment in which they're taking place in. So it's hard to tell whether or not your percent yield is actually good or not from just doing the calculations. Okay, so let's go back, let's stay with this example. I now know that I have a 75.3% yield. Here's a different kind of question to add to that. What mass of ammonia would you need to start with in order to produce 10 grams of nitrogen monoxide? And of course, we'd have to assume that we had excess oxygen, so we don't have to worry about the amount of oxygen we need. I'm going to want to produce 10 grams of nitrogen monoxide. Well, now let's look at what I know. I know that my yield for this reaction is 75.3%. And I know that my experimental, or my actual amount of nitrogen monoxide I want to form is 10 grams. What I don't know is how much my theoretical mass of nitrogen monoxide should be, right? Or that would be our target mass that we would really be shooting for when we did the actual reaction. But I have my percent yield equation, experimental yield over theoretical yield. So I can manipulate this equation algebraically to solve for my unknown. So my unknown here would be my theoretical yield, which would equal my experimental yield, which I know, over my percent yield, which I also know. So what do you get for your theoretical yield of the nitrogen monoxide? Putting in the values we know, we should have gotten 13.3 grams. And notice that I did change the percent to a decimal before adding it in there. So let's take this problem and see how much ammonia would I need to start with if I wanted to produce 10 grams of nitrogen monoxide. Well, I just found out that if I want to produce 10 grams of nitrogen monoxide, I really have to do my calculations as if I was going to produce 13.3 grams of nitrogen monoxide, because I'm only going to get a 75.3% yield. So do the calculation now to determine how much ammonia you will need if you're going to start with 13.3 grams of nitrogen monoxide. So your stoichiometry is going to look the same as it always has, starting with 13.3 grams of nitrogen monoxide, converting that to moles, using my magic mole ratio to convert that to ammonia, and then the molar mass to convert the moles of ammonia to mass of ammonia. And you should have gotten an answer of 7.55 grams of ammonia. Now again, that means that if I start with 7.55 grams of ammonia and plenty of oxygen, I should be able to produce at least about 10 grams of nitrogen monoxide, right? Not the 13.3 grams that I would theoretically get, but the 10.0 grams that my percent yield indicates that I would actually get. Now, if we were in the lab, of course, I'd probably use a little more. I'd probably use maybe 10 grams of ammonia just to be on the safe side, right? But that's a laboratory practical idea versus a stoichiometry idea. Now, of course, it's time for you to practice. More practice problems, adding this additional concept onto the idea of limiting reactants and stoichiometry.